Hi folks, so this is question 7. So you need to just show that the total length is 62 here. So it gives us two of the distances. So it says that from C to B is 4, so 4 kilometers. That's the length of the swim. Then we're missing the bit from B to A for now, and then the bit from A to C is 28 kilometers. So 28 kilometers from A to C. And it gives us what we need then. So you'll know from the DST triangle that distance is speed multiplied by time. So what we need to just do here is the distance. So the speed, we just need to do the speed multiplied by the time for the cycle. So the cycle, Mary can cycle at an average speed of 25 kilometers per hour, and it takes her 1 hour and 12 minutes. Now just look at that 1 hour and 12 minutes for a second. I just want to change it fully into hours, because we want to give our answers when we're dealing with in kilometers per hour for the speed. So 1 hour and 12 minutes, if you think of what 12 minutes is as part of a minute, as part of an hour, it's 1/5 of an hour, isn't it? So it'll be 1.2 hours then. So that's the same thing as 1.2 hours. So if we do 25 multiplied by 1.2, that is 30. So 30 kilometers. So that's what's missing there then, 30 kilometers. That's the length of the cycle. And then if you add the three things together there then, so 4 plus 28 plus 30, that will give you 62 kilometers. So that's shown. Right, so on average, Mary can run 5.6 times as fast as she can swim. It takes her 4.8 hours to complete the course. So we can come up with an equation here. So 5.6 times whatever her speed of her swim is, that has to be equal to the speed of the run. So that's an equation, and we can figure out kind of, there's one thing that we don't really know here. So remember, speed is distance over time. So 5.6 times, and it's the distance over the time of the swim, is equal to distance over time of the run. So let's think about it for a second. So 5.6, you can fill in the distance of the swim. I know we know all the distances. The swim was 4 kilometers. The time though, we're not so sure about. We know that altogether it takes us her 4.8 hours. So if we do 4.8 and we take away the other two times that we know, so we know that the time of the cycle from the first bit is 1.2. So you can take away 1.2 there, and you can also take away the length of the run, but we don't actually know what the length of the run is. So in this case, I'm going to let that be t, and that'll be what we're going to figure out here from this equation. So the length of the time it takes for the run, and that equals the distance. So the distance of the run, and the run was 28 kilometers, over t, like that. So yeah, so t is the same thing on both sides there. So we're left with an equation with a variable of t, and you can go and figure out what that is then. So we're going to multiply 5.6 by 4 on top. So we get 22.4 over, and then it's 3.6 take away t. That's when you subtract 4.8 and 1.2, and that will be equal to 28 over t. And when you get to here, then you can cross multiply. So 22.4 t has to be equal to, and it'll be 100.8, and it'll be just take away the 28t. So you're going to get 50.4 t. You're just bringing across that 28t to the other side equals 100.8, and you might be able to spot these actually divide into each other. So when you bring across the 50.4 and you divide it, it just goes in twice. So t equals 2. So t is 2 hours. So it takes 2 hours for the run. That's the run time. Now if you look back at the question though, that wasn't what was asked. So the reason we did that was to get what t was, because we needed it in order to get the speed of the swim. It's the swimming speed. So this is what the swimming speed is in that circle there. That was kind of what we came up with for what the swim speed was, but that was in terms of t. But we know what t is now, so you can just go back and you can put in the 2 instead of t. So it'll be 4 over 4.8 minus 1.2 minus 2. So when you put all that in together, then our final answer should be 2.5, and that's just kilometers per hour. So that's it then. That's your final answer. So that was just the way I wanted to work out what t was. So the biggest thing there was to work out the running time, and then you kind of have everything else then. So you can just work out the speed of the swim. Right, so next question. So show that ACB is 116.5 degrees. So we just have to go and work out what ACB is. So if you look at the question, ACB has to be this angle here. So you can see that it's not a right angle triangle, and you've got three sides, and you're looking for one of the angles. So it's a basic enough cosine rule here. So it'll be a squared equals b squared plus c squared minus 2bc cos a. So the a will be the 30 because that's furthest away from the angle there. And the b and the c will be the 4 and the 28. It doesn't matter which one is b, which one is c. And it'll be cos of the angle, so cos of, we'll just call it a maybe. So it's a basic enough cosine rule. So you can look up the cosine rule in your log tables as well. It'll give it back to you. So 30 squared equals 4 squared. Sorry, yeah, so plus 28 squared minus 2 times 4 times 28 cos of, and we'll just call it a. It doesn't really matter what you call it there. So you can go ahead and just kind of multiply those out or simplify it. So we get 900 for 30 squared equals 16. And we'll just add them to them together maybe. So we get 800 minus 224 cos of a, and then if you bring over the 800, it'll become 100. So 100 equals minus 224 cos a, and then bring over the minus 224 and divide it, so we get 100 over minus 224 equals cos a, and then the last step will just be to do cos inverse then. So a is the cos inverse of minus 100 over 224, and we get 116.5. So that was what we were supposed to get. That's what they asked us to show in the question. So that's it. That's part C. Right, so part D then, it's find the area. So it's just a triangle really. So you have a formula there in your log tables for the area of a triangle. If you look back up to it again, you're just finding the area inside that triangle, and you know now that that is 116.5. So there's a formula there, it's called a half AB sine C. So this formula will work out the area of any triangle as long as the C, the angle C, is in between the two sides A and B. So you just have to use the two sides that are either side of 116.5 for this. So you can just sub them in, so it'll be a half times A will be 28 and B will be 4, doesn't matter which one is which there, you could put 4 first if you want, times by the sine of the angle. So the angle is 116.5. And then you just put all that in the calculator together and it'll give you the area. So it's 50.1 kilometers, and it's kilometers squared because it's area. So that's it for part D. Right, so this bit, I just rub out that then. So that's answer to part D, and we have 50.1 kilometers squared. So I'll just rub that out just so we can see the next question. So you have to find the shortest distance from point C to the side AB. So give your answer in kilometers. Right, so I'm going to use what we just used a second ago here. So we've just worked out that the area was 50.1, so 50.1 kilometers squared. So that was when we used that formula, that half AB sine C. But the real simple formula for area of a triangle is half times base times height. So you would have learned that way back in even first year or second year. So half times base times height is 50.1. So that's just another formula for the area of it. Really what you're looking for here, you're looking for the shortest distance from C to the AB. So by definition, from C to AB, that has to be what the height is. So that has to be that distance there. It's going to be the shortest way down. So that is just going to be what the height of the triangle is. So you're just trying to work out what the height of the triangle is. It's just a different way of asking it. So we know that the base is 30. So half times 30 times the height is 50.1. So then you can just move things over to the other side then. So you get 100. So if you move the half over, you get 100.2, just timesing it by 2, that is to equal 30h. And then you can just divide by 30. So you should get 3.3 in the end. They ask you to round it off to one decimal place here as well. So 3.3 kilometers would be what h is. So that has to be the shortest distance then. Right, so for part F then, part F is actually a nice easy question for a part F for the end of one of these, and it's the last part. So so the angle of elevation of T from B is 0.05 degrees. So of T from B, so draw this as straight as I can. So that angle there has to be 0.05 degrees. So it's half of yeah, so it's very small angle. We already know back from the start of the question that down here this has to have been 30. So you know that right from part A of the question, from A, so A to B is 30. And all they're asking for here is to find AT, so to find from A to T. Now you know that this is a right angle because it's just a pole sticking up in the air from the ground, basically. It's a camera tower. So that has to make a right angle there like that, with that line. Might not look like it really, but it makes a right angle with that, and it also makes a right angle with that line as well. So it's a right angle triangle, and all you're going to use is SOHCAHTOA. So you're using tan here, I think. So that's the opposite. That's the adjacent. So you're looking for the opposite here. So we'll just call the opposite x. So x over yeah, well, tan of the angle 0.05 is equal to x, which is the opposite over the adjacent, which is 30. So we just do 30 tan of 0.05, and that has to be what x is. So when you put that in your calculator, you get 0.02617 let's say 18, we'll just round it off, equals x. Now it asks in the question to give it your answer to the nearest meter, so you just need to be careful here because the whole way through this we were dealing in kilometers really. So you have to change this number into kilometers. That's in meter. That's in kilometers. We need to change it to meters. So we need to change that from kilometers to meters. So to change from kilometers to meters, you times by 1,000. So you're basically moving the decimal point 3 places. So it goes in there. So it'll be 26.1, and they wanted it to the nearest meter. So that's going to be it. So 26 meters. And that's it. That's all you have to do for the last part. So that's the end of question 7.